Okay, this is homework sheet part 5, I believe. The problem is the integral of sine to the 6th x cosine to the 3rd x dx. The first step is to use your trig identities to turn the cosine squared into 1 minus sine squared x. Then you rewrite the problem. As you can see, I replaced the cosine squared over here with sine squared x minus 1, but since it was cubed, there's still one left over. Then you use u substitution, using sine u. Derivative of that is cosine x. That takes care of all our stuff when we rewrite it. So that we have the integral of negative u to the 6th, parentheses u squared minus 1, du. The du is that cosine x turned into the du. Then you continue to simplify. I tried to write out every step so I wouldn't have to explain that much. Here you can see that if you take the problem apart and solve for the u to the 8th, it becomes u to the 9th over 9. Over here, you solve for u to the 6th equals u to the 7th over 7 equals. Replace your u's back in, and then your final answer is sine to the 6th x cosine 3rd x dx equals sine to the 7th x over 7 minus sine to the 9th x over 9 plus c. For number 2, this one's way easier. You just use u substitution. 1 over x. du is negative 1 over x squared, which gets rid of the bottom part there once you rewrite it. So it equals negative e to the u du, which is really easy to solve. It's just negative e to the u plus c. And then you put in your 1 over x again, and it equals negative e to the 1 over x plus c. Lastly, evaluating e to the 3x sine ex dx. First, use a u substitution. I believe in this problem you use multiple u substitutions, so it does get a little hairy. The u substitution we're using is u equals e to the x. Du or the derivative of e to the x is just e to the x dx. Rewriting the problem equals u squared sine u du. And then I tried to separate them a little bit, but as you can see in my work, it's not really going to hold true. But this is the new u that equals u squared. Oh, this is integration by parts, by the way. U squared. We got dv equals sine u coming from that problem. And then the integral of u is 2u here, and the derivative, the derivative of u is 2u, and the integral of dv is negative cosine to the u. When you rewrite that problem, you get negative u squared cosine u minus the integral of negative 2u cosine u du. Then you use u substitution again. This time u is u and dv is cosine u. du is 1 and v equals sine of u. Rewrite it again. And then at the very end, after rewriting it a few times and putting back in your original values up here, you'll get 2e to the x sine e to the x minus e to the 2x cosine e to the x plus 2 cosine e to the x plus c.